In this video, we're going to talk about a unit vector and how that can be used in creating a linear combination. Now, what is a unit vector? Well, a unit vector is a vector with magnitude of 1. Remember, magnitude means length. So if v is a given vector, and as long as v is not equal to the 0 vector, then if we take 1 and divide it by the magnitude and multiply it by the vector, or rather if we just take the vector and divide it by the magnitude, we will get a unit vector of length 1, which is in the same direction as the original vector v. So, for example, we are given the vector w here with components -3, 5. If we are asked to find the unit vector, we first then need the magnitude. The magnitude of vector w is the square root of -3 squared plus 5 squared, or the square root of 9 plus 25, which is the square root of 34. So the square root of 34 is the length of this vector. And if I take this vector and divide it by its length, I will have a vector length of 1 in the same direction. So that means my unit vector, we'll call that u, is equal to the vector w divided by its magnitude, or -3, 5 divided by root 34, which gives us the vector -3 over the square root of 34 and 5 over the square root of 34. You may be asked to rationalize this, I'm not sure, but you could give this vector the same way, -3 root 34 over 34 and 5 root 34 over 34. And if you went and found the magnitude of this vector, if you squared each of these two numbers and you summed them together, took the square root, you'd get the value 1. Now, why are unit vectors useful? Well, we use them a lot moving forward when we really start talking about vectors in Calc 3, but they're also helpful in helping us establish what we call a linear combination. So, although unit vectors can point in any direction, the only specificity with a unit vector is that the length is 1. We have two special unit vectors. We have a unit vector that is parallel to the x-axis, and it's also parallel to the y-axis. So we have I, which is 1, 0, and vector j, which is 0, 1, both in component form. Any vector, then, can be expressed as a linear combination of these two vectors. So if I'm given a vector v with components horizontal v sub 1, vertical v sub 2, let's think about developing this definition here. Given our vector, I can, in a sense, unadd. So I can say v sub 1, 0 plus 0 v sub 2. And I can check this by adding these back together. So if I have it written like this, I can factor out a GCF v sub 1. That leaves me with 1 v sub 1, 0 v sub 1, 1 and 0. I could factor out v sub 2, which leaves me with v sub 2, 0, 1. 1, 0 is equal to I, and 0, 1 is equal to j. So we can take this vector and rewrite it in a different form. V sub 1 I plus v sub 2 j. I and j are both unit vectors. So for example, if we were given this vector 2, -6, we might be asked to write it as a linear combination of I and j. All that would mean would be take vector r and rewrite it as 2i, 2 horizontal units, minus 6j. -6 vertical units. So this is just a different notation for vectors. We have one other property or operation that we apply to vectors, and it's useful for finding the angle between two vectors. That's the dot product. The dot product is useful to find the angle between two vectors. We have a formula that we're going to talk about in a minute, but in order to use the formula, we need to know what the dot product is. Given a vector u with its components and v also in component form, u dot v, that's bigger than a multiplication symbol. Okay, so when we're dealing with vectors, we don't write a multiplication symbol. This is u dot v, and this is a special type of multiplying and adding. We multiply the horizontal components and add them to the product of the vertical components. So u dot v is u sub 1, v sub 1, plus u sub 2, v sub 2. And we'll do an example of finding the dot product when we do this next piece, which is where we find the angle between two vectors. And this is just a helpful formula that sometimes we use. So if we know that theta represents the angle between two vectors u and v, which are both not zero, then cosine theta is equal to u dot v divided by the magnitude of u times the magnitude of v, both of those in the denominator. This is a formula you may be required to use on your test, and it would be something you might want to know. Let's find the angle between two vectors. So we have u given here as 6, 3, and v is given as -4, 2. In order to calculate this angle, I need u dot v. I also need the magnitude of u and the magnitude of v. U dot v, u dotted with vector v, that means I'm going to take 6, multiply it times -4, both of my horizontal components, and add to that 3 times 2. The dot product here is -24 plus 6, or -18. So -18 is what's going to go in my numerator. I now need the magnitude of u as well as the magnitude of v. The magnitude of vector u is the square root of 6 squared plus 3 squared, which is 36 plus 9, the square root of 45. And the magnitude of v is the square root of -4 squared plus 2 squared. So 16 plus 4, that gives me the square root of 20. Therefore, by my definition, I can write that cosine theta is equal to -18 divided by the product of these two magnitudes. And I'm going to go ahead and just reduce each of these. 45 is 9 times 5, so that's the same as 3 root 5 when I take the square root of 9. And 20, root 20, is 2 root 5, because that's 4 times 5. Square root of 4 is 2. So this gives me 3 root 5 times 2 root 5, or rather that the cosine of theta is -18 divided by 3 times 2, 6. -18 divided by 6 is -3 over root 5 times root 5 gives me 5. And theta equals cosine inverse of 3 over 5, which gives us roughly 53.13 degrees in degree mode. So that'll conclude this video. In this video, we talked about linear combinations, unit vectors, the dot product, and then also the angle between two vectors.